Okay, so as I was saying, kung kinuha natin yung log ng difference data, you'll have error. Hindi pa pwede kasi yung DAP natin, if you recall, yung tail DAP. Di ba may mga negative numbers? May mga negative numbers siya, so it will not, you cannot get the log of that. So what it is suggested that instead of getting the difference, you may get the log first. Sige, let's do this. Let's create this object called LAP log, and let's get the log of AP. Let's see what happens if we get the log of AP. So ang head natin is LAP 10. Okay, so you notice ito na yung mga values natin, ano? 4.7 kasi kinuha na natin log ng bawat value niya. Okay, let's plot that. I-plot natin siya dito sa, okay, you don't have to ito na lang, no? Let's see what happens to the plot of the log of our time series here, L, no? LAP, plot natin. Ay, mali, sorry. Wala, yung auto plot. LAP. Okay, what do you notice, class? We notice here that when we got the log, ano nangyari? Okay, naging constant yung variance, no? The variance became constant. Wala naman siya, wala na yung increasing over time na ganyan. Okay? This was removed. However, may trend pa rin. May trend pa rin siya. So, pag ganyan, so yung order importante, it's best to first get the log and then get the difference. So, sige, gawin natin yun. Since may log na tayo ng AP, let's see, the difference ng log AP ngayon. So I created this object now, which is the difference of my log AP. So first, we get the log, and then we get the difference. Okay, so this is now getting the log and getting the difference. Possible na may mga negative numbers tayo. Kasi magma-minus tayo eh. Pero walang error terms tayo dyan. Walang not applicable, walang NAs. So let's plot that and let's see what happened. So difference ng log AP. Okay, take a look now. Okay. Comment please. Ano nangyari dun sa original na data natin na AP? Airline passengers. We said that we cannot model that using Box Jenkins ARIMA kasi hindi siya stationary. Ngayon ito. Stationary na ba siya? Comment please, guys. Is our data now, and take note guys, this is now a different time series. Hindi na to yung AP natin. Yeah, thank you. Ano na siya, no? Naging stationary na siya. Kasi wala na siyang trend. Okay, wala na siyang seasonality. Non-constant, non-constant variance, constant variance, and constant mean. So these are the attributes of a stationary data series. Okay. So plinat natin, tinan din natin, plus tinan natin yung yung ACF at saka PACF niya. So let's go here. Let's take a look at, let's just replace this by difference log AP. Difference log AP. Plot natin. Okay. Alright. So, meron pala tayong nakikita mga meron tayong makikita mga autocorrelation sa in different logs, no? Sa ACF at saka sa PACF. We see some autocorrelation. Pero ngayon guys, this, unlike yung kanina na talagang slow decay siya, ito may mga significant spikes lang at some lags. So ito na ngayon yung gagawin natin na i-model natin siya. But before we model it, we can have this statistical test. Okay. Did we did we do guys the last time? Did we check using ADF? Wala siya dito. Nasaan na yung 8? Ito to. Okay, let's copy this. Dapat dito natin ilagay ito. Sorry about that. So let me put it here. Okay, let me paki-insert to guys, no? Kasi tayo, di ba, dito nag autocorrelation function. Tapos dito, we can test statistically kung stationary nga yung data natin. Let's first test yung AP natin, yung original data natin. And we're going to use the augmented Dickey-Fuller test. So this is your augmented Dickey-Fuller test. Ano HO natin dito? Our null hypothesis here is okay. So let's run muna ito. Okay, take a look at this, no? Augmented Dickey-Fuller test. Data natin AP. Okay, the p-value is equal to 0.01. Alternative hypothesis is that the data is stationary. Therefore, ang null hypothesis natin dito, our data is not stationary. Okay, for the AP dataset, the p-value is 0.01. Therefore, we reject P-series, ADF test, AP. Ang null hypothesis natin is not stationary. Alternative hypothesis natin stationary. Okay, something's wrong. Kasi ang p-value natin 0.01, therefore we reject the null hypothesis that the time series is not stationary. Ibig sabihin, stationary siya. Let me check. Huh? Pero tama dapat yun. So, tama. Okay. Guys, something's wrong with with our results here. Okay, I'm looking at this. No? Very good. Okay. Ulit ah. Okay, we're testing yung Apple natin. Alam natin na hindi stationary yan. So we're using the ADF.test from the time T-series package. So if you run this, okay, bakit AP? Sandali ah. Ano nangyari sa AP natin? Nagamit ko ba yung AP siya? No? 1-1. Tama, ito yung series. Okay, so we're testing whether AP, our data, is stationary or not using the augmented Dickey Fuller test, T-series from the package T-series. So this is the code. And then it tells us that the p-value is 0.01. Therefore, we reject natin null hypothesis na not stationary siya. So ibig sabihin stationary, which is wrong. Okay, guys, can you nakikita niyo ba yung nahabol niyo? Pause muna ako. And I'd like to seek comments from you if you're able to follow this. Any comments? Okay, same then from you. How about the others? Same. Okay, we're having we're having a problem here kasi nung tinest natin statistically, si AP dapat not stationary yan. So dapat ang p-value niya should be greater than 0.05 so that we fail to reject the null hypothesis that the data is not stationary. I'm wondering why it's giving us 0.01. I'm checking the ADF.test. Ngayon lang nangyari sa akin to na medyo nagka-problema yung result ng augmented Dickey Fuller test. Now, si augmented Dickey Fuller test, as literature says, it's used to determine, computes the ADF test for the null hypothesis that X has a unit root. Ang ibig sabihin ng has a unit root, ibig sabihin nun, not stationary siya. Let's run some examples here. Control C. Okay, I'm going to copy this. So this is, I'm creating an object called X, which is random lang, 1,000 random numbers. Okay, and then i-ADF test natin si X. Since random lang yan, normally distributed, dapat ano yan, ADF.test si X. Okay. Stationary. Oo. So ito tama, no? Stationary talaga siya. Pero bakit si AP, which is supposed to be not stationary, bakit ano? Bakit sinasabi niya na stationary si AP? Okay. So we will ano no. Let's first first time lang sa akin nangyari to na ilang beses ko nang rinan si AP na ano eh, kung test kung stationary siya o hindi. Dapat we know guys that AP is not stationary. So why does the augmented Dickey Fuller test suggest that AP is stationary? Bigyan ko lang dito ng ano ng check why ADF test shows data to be stationary when it is not. Okay. Sige. Okay guys we'll skip this. Okay. Sabi ko, bakit si AP lumalabas na stationary? Pero pag check natin, let's now check Control C, Control V. Yung kanina, yung difference log AP. Let's now try to check this. Difference log AP. Let's try to check if it's stationary. Okay, so ito. So si difference log AP tells us that this data is not stationary. Is stationary. Since the p-value is 0.01, it is less than 0.05, then we reject the null hypothesis that DLAP is not stationary. So we have proven that DLAP is stationary. Dali nga, guys, i-load ko nga si data. Okay, let me download data again, si AP. Ay, sorry. Okay, let me use bakit kaya si AP yan? Air passengers yung data. Pareho lang naman ni ano yan eh, ni AP. I'm just curious why. Oh, ganun din. Air passengers is also stationary. Okay. We're having a problem with this one. Kasi air passengers or AP pareho lang yun. And they're not stationary. Bakit si augmented Dickey Fuller sinasabi na stationary siya? Okay, so let's skip that. I will have to resolve that. Hanapin ko kung bakit. Ganun yung reason. But to say, class, this is the first time I encountered that problem na nagkaroon ako ng problem as far as dun sa ADF test is concerned. Okay. So before we solve yung sa ARIMA, no? Mag-simulate muna tayo dito ng data. So here, we're going to make use of the stats package. Meron siyang function na arima.sim where we can simulate an ARIMA model. Okay, so let's create now. Para pare-pareho tayo ng data, set that seed 1, 2, 3, and then we're creating an object called A1, and then magsasimulate siya. We ask it to simulate a data set that's an ARIMA. Okay, ang model natin, gawin natin ARIMA is equal to 0.8. Ano ibig sabihin itong ARIMA 0.8? So yung model natin will be the coefficient of the y sub t minus 1 will be 0.8. Yun ang ibig sabihin nito. Okay, so 1,000 yung observations. Then, plot natin to. So let's run this. Control Enter. Okay, so once again, hindi niya generate. Head na lang A1, 20. Okay, paki-check. Class yung mga values nyo, dapat pare-pareho tayo. So, feedback please. Did you get the same values? Okay, feedback guys kung same yung values natin. So we're creating an object called A1, and then ano yung laman niya? Gusto natin na yung object na to follows an ARIMA series. No? Okay, good. Same. Yung mga dito head. Kasi yung view, hindi niya pinaplot yung ano, hindi niya piniprint yung ano. And then let's plot this. Plot the TSA1. Okay, you can see that the data generated, okay, is stationary. Why do I expect this to be stationary? Kasi pinaplot natin is an ARIMA process. ang coefficient niya 0.8. So remember, an ARIMA process is supposed to be stationary. Okay. Tapos, let's ask R now. This is from TSM, di ba? TSM package to. Yung autocorrelation function ng A1. Let's plot this. Okay. So, ito na yung gagamitin natin guys, yung autocorrelation function to determine kung ano yung model na to. Okay, let's take a look at this first. We have to understand kung anong model to. No? All right. So in order to determine if a series is an AR process, what we look at is the PACF. Ito yung tinitingnan natin para ma-identify natin kung AR process to. Now, if the PACF has a significant lag, okay, ito isa significant lag at lag 1. Pero wala na sa iba, no? Isa lang significant. Significant at lag 1, and then you take a look at the ACF, tapos ACF, slow decay. Okay? Slow decay ng autocorrelation function. Then this is indicative that this is an AR process. Bakit? Kasi ang AR process, ang behavior niyan, it's significant at the PACF, partial autocorrelation function, tapos slow decay siya, pwedeng ganito or pwedeng nag-alternate yung decay niya, gumagano. Sa ACF, no, sa autocorrelation function, slow decay. Ang tawag dito, slow decay ng autocorrelation function. Dito, significant lag. Okay, so an AR process behaves that way. Now, it's significant at lag 1 only. So, ibig sabihin, malamang to, AR1 process. And we know, guys, that this is an AR1 process kasi simulated data lang to. Diba? Nung pinasimulate natin, AR is equal to 0.8. Ibig sabihin, isang significant lag lang. So, AR1 lang yan. Okay, so how do we know if it's an AR1 process? It's significant, significant spike, significant lag at 1, and then slow decay dun sa ACF. So to determine if it's an AR process, titingnan yung PACF. Dapat significant doon yung lag, significant spike yung lag, tapos sa ACF, slow decay siya. Pag na-reverse yan, class, pag ang significant spike nasa ACF, tapos slow decay sa PACF, then that is an MA process. Okay? Pag parehong significant sa PACF at saka sa ACF, then it's indicative that it is an ARIMA process. Okay, so dati, nung napaka-manual pa nitong pag-solve ng ARIMA, mabusisi kasi pag-compute ng ACF at saka PACF. Good thing for us, it's generated already by a software called R. Dati kino-compute pa namin 'yan para malaman lang kung AR process ba o MA process o ARMA process. Again, paano malalaman kung AR process? Significant spike at the partial autocorrelation function. Tapos sa ACF, autocorrelation function, dito, slow decay siya. Yan, slow decay. Dito, significant spike. 1 or 2 or 3, depende. Pag MA process to, baliktad siya. Si ACF, significant spike at 1 or 2 or 3, tapos slow decay sa PACF. Pag pareho silang significant spike at ACF and PACF, indicative yun na, na ARMA process. Okay? Alright, pause again guys. I'm sure medyo, medyo nakaka-lito din kasi, kaya nga I felt that I need to repeat this. Even if you have watched the video. Okay, pero i-watch it guys kasi ando dun yung explanation. Naka-record naman dun yung explanation. Okay. Any questions so far, guys? Paano natin malalaman kung AR process or MA process or ARMA process? Clear ba? Or questions? Kailangan ko ng feedback, guys. Gusto malaman kung nagkakaintindihan tayo or malabo siya. I need feedback from you, please. Okay. Thank you. Thank you, Willie. Thank you, Samir. Yung iba? Okay. Alright. Okay. By the way, guys, ito, sinuspend muna natin yung itong sa hindi. Asan yung natin? Yung i-plot ko lang dito yung yung kaninang ginagawa natin, yung D, pasensya na medyo D log AP, just to show you. Okay. Alright, so nakikita natin dito yung difference ng log ng AP, may mga significant spikes siya, no? So significant sa 1, significant sa 4, marami siyang significant spikes. So it's indicative na If you take a look at the ACF, may significant spike siya at several logs. So indicative to na AR process siya. Tapos ganun din sa ACF, ano din siya, significant spikes at certain logs. Therefore, malamang yan yung ano natin, yung difference log na AP, that's an ARMA process. Okay? ARMA process yun ang tansya natin that based on the ACF and the PACF. ARMA process yun. Importante yan dati kasi you will have to identify a possible model muna. And then i-compute natin kung ano yung model na yun. Tapos i-check natin, i-diagnose. And then have another computation, have another model, then compare. So ganun dati. But now guys, with the advent of softwares like R, we don't have to bother ourselves with having to do some iteration in solving what ARIMA process that is. Kasi R will already give us the model for that. Okay, so balikan lang natin to. Okay. So take a look at this. So we're creating this object called ARMA10. ARMA10 kasi, di ba, based on the PACF and the ACF, nakita natin dito na this seems to indicate that this is an AR1 process. Kasi yung PACF niya, significant spike, significant lag at 1, and then yung ACF niya, slow decay na. So AR1 yan, yung ganyang behavior. And alam naman natin talaga na AR1 process yan. Reverse lang natin. No? Reverse natin yung process. Ang ginawa natin, nag-simulate tayo ng data that has AR1 characteristics. Ito, ARIMA simulation. Ang model natin, AR equal to 0.8. And then, plot natin siya as expected, stationary yung data natin. Tapos, pagdating dito, nung kinuha natin autocorrelation function, as expected, significant spike yan sa PACF and then slow decay sa ACF. This is what we were expecting. Kasi yung data natin, yung A1, it's an AR1 process. No? Okay, now let's run this. So ito, we can use the ARIMA function in order to determine a model for A1. Okay, reminder lang, class, yung A1 is an object that we created based on that simulated data. Diba ito? 1,000 observations yan. And it was a simulated data, diba? Based on arima.sim natin. Okay? Itong model na to, class, it will give us a data which is an ARIMA data. And pare-pareho tayo kasi nag-set.sim tayo. No? Okay, 1,000 observations. And then when we plotted it, diba, we expected it to be stationary. Okay, and when we plotted the autocorrelation, we expected it to be significant at the PACF, okay, sa lag 1, and then slow decay sa ACF. Kasi ganun yung nature ng isang AR1 process. Okay. Now dito, we're going to ask R to develop a model. Anong model kaya ito? So sabi natin based on the PACF, ARMA AR1. Although guys, alam natin na AR1 yan. So we're just reversing the process as I said. So ang function yan, ARIMA. No? A1 yung object natin, order is equal to C100. Okay. Ano yung 100? This is log 1 ng AR, 0 integrated, hindi difference, 0 MA. Include that mean is equal to false. So ibig sabihin, hindi niya ilalagay muna yung mean. No? Para napaka-simpleng model lang. Okay, so let's print ARIMA 10 natin. So let's print this. Okay. Alright. And ito yung sinasabi na solution ni solution ni R. So coefficients AR1 it's equal to 0.77. So it's approximately 0.78, no? So quite close to the simulated value na natin. Diba yung actual value ng data natin is 0.8, no? So if we're going to round it off to 1 decimal place, tama ito. Ito yung sabi niya na ang ano natin, ang model natin for that is, okay, ano yung model natin will be, so let me write that. Our model will be A1 kasi object natin, di ba, is equal to 0.7783 times A1 t minus 1. Okay, ito yung ano natin. Ito yung AR process natin, di ba? Yan. So that's our model. And it did not include the mean kasi naglagay tayo ng include mean is equal to false. Pero pag linagay natin mean is equal to true, so let's do that. Okay. Here we're just getting the basic model. Pag ginawa natin itong include mean dito, include mean is equal to true, magbibigay ito ng value na for the mean. There. So ito yung mean natin. So our model is I'll just call it y sub t. Y sub t is equal to 0.1153 plus 0.772 times y sub t minus 1. Okay, so that's our model. So it's close, di ba? Close dun sa natin, sa expected value natin na 0.8. Yung simulated value natin na 0.8. Alright. So meron ding auto.arima. Ito, this is one of the disadvantage of this, itong tayo mismo pag-aano ng model, iterative to. Iisa-isahin natin. Baka ARMA 1.1. Baka ARMA 2.0. We don't know. Kasi ito, ang chine-check lang natin yung 1.0.0 lang. Okay, what if it was, ilan ko ulit to Okay, so dito, ang ano niya, ang lumalabas, AIC niya, naalala siya AIC, di ba? Akaiki. 2850. 2850 yung akaiki natin. Eh kung lagyan natin ng false dito, yung walang walang mean. Run natin to. Ano lumabas? 2848. 2848, yung isa 2850. So mas maganda pa yung walang mean. Mas maganda pa yung component lang natin, yung AR1 lang, yung 0.7783. Kasi mas mababa yung AIC niya. Mas mababa yung akaiki niya. AIC is 2848, yung walang mean. Yung isa namang may mean, 2850. Okay, what if it's 2.0? Yan. Paano kung ARMA 2.0.0? Let's see, print ulit natin to. Okay, so you now have, okay, yung AR2 niya, guys, 0 rin talaga. Okay, 0 din. So walang walang component din yung AR2. Sabi niya, it's 0.0.0. Okay. All right. So, and then, okay. So, sabi ko nga kanina, pag ganito, yung manual natin, isa-isahin natin. Now, for this one, ito, ano nga natin to, separate natin to. Ito, this is sabi natin powerful code kasi automatically bibigyan tayo ng different models. So ito, A1, trace is equal to 2. Ibig sabihin yan, ibibigay niya sa atin lahat ng possible models. So let's run this. Okay, so take a look now. Okay, so it's giving us different possible models. Okay, ito yung with non-zero mean at saka yung with zero mean. Okay, so if you take a look at this, ang lumalabas dito, ano yung best model? Ang best model natin is turns out to be this one. Yun. By virtue of having the lowest AIC. ARIMA 100 with 0 mean 2846.909. Now, you notice that there's a difference between the computation of the AIC a while ago kasi kanina 2850 at saka ngayon. So, it's okay. May difference lang sa pag-compute nila. But what's important is determine ano yung pinaka-best model. So, based on the AIC, yung AKAIKI natin, AKAIKI Information Criterion, the one with the lowest AKAIKI is ARIMA 100, which is what we expected. Kasi nga yung data natin, sinimulate lang natin yun. Okay. So yun yung model daw. It's ARIMA 100 with the AKAIKI 2848. Okay? So ito, now refitting the best model without approximations. So pinili niya yung best na model, ARIMA 100. The best model is ARIMA 100 with zero mean. Okay? So ito yung ito yung lumabas kanina. So this is our model. Okay, AR1, 0.7783, standard error, 0.0199. And then AKAIKI is 2848. All right. So pause ako. Okay, clear ba so far? Any questions? Paki-chat naman so far kung clear, guys. Thank you, Samir. About the others? Thank you, you. Yung, thank you. Okay, meron pang comments? Kung clear so far? Okay, Steph, thank you. All right. Okay, majority naman so far. Clear. Okay, so ito, class, ito. So kung tutuusin, dito in-illustrate sa atin nito na this illustrates to us that we can automatically already determine the best ARIMA model. No? Itong auto.arima. This really facilitates the computation of the ARIMA model. Okay, but it's important for us to understand first ano yung proseso nangyayari before we go here. Kasi mas ma-appreciate lang natin itong auto.arima kung alam natin kung ano nangyari. So dito kasi ang ginawa niya, it went through different models. Ito yung sinasabi ko sa inyo, nag-iterate tayo. Kasi based on the ACF and TACF, we can only guess na ito, mukhang AR process to kasi significant at ACF and slow decay dito sa ACF. So this is indicative of an AR process. However, we're not yet sure. Okay, so ang ginagawa dyan, nagtitingin ng ibang models and try to see if that model is the correct model. So, iterative siya, yung process na yun. Okay, so this time, let's see. Let's continue the process. Now take note that our model, itong model natin, yung pinamodel natin, yung, diba 100 siya? Ito yun, no? So let's run this. So ito yung ARIMA 1010 model natin, which turned out to be the best model, no? Kasi walang mean, tapos yung AR component niya 1. Okay, so this is the best model. This is the model for the object A1, yung simulated model. Hindi ito, guys, yung AP mod, hindi ito yung AP data. Okay, so let's continue this. Now let's analyze now. Just like in your regression, once we were able to determine kung ano yung model natin, it doesn't stop there. No? We will have to diagnostics. No? So magda-diagnostics pa tayo. So let's take a look at this. Right? Ano ba yung laman ng just like in regression, yung object na to na ARIMA 10 it's just like a regression object. So ito yung mga laman niya, may coefficient, may log likelihood, number of observations, yung model, etc. So it's a list. It's a list of different objects. So pwede natin makita, for example, yung ARIMA 10, asa yung mga residuals yan. Okay, again, hindi natin makikita dito. Okay, so let's just plot. No? I-plot natin from ARIMA 10 yung mga residuals. Okay, so you notice that the residuals itself is stationary. Okay? So yung object natin, yung A1 natin, stationary. Yung model natin is AR1. Okay? And the residuals itself is stationary. So okay yung residuals natin. Okay, then let's check the autocorrelation function ng residuals. Okay. What do you notice about the residuals? What do you notice about the residuals? Huh? Anyone, guys? How do you comment on the residuals? Take note, ang plinat natin dito, hindi yung A1 na data. Ang plinat natin yung residuals coming from the ARIMA 10 model. And if you notice the residuals, ang tawag dyan, class is white noise. No? White noise na siya. Parang mga random fluctuations na lang. Walang significant spikes. Walang autocorrelation. Diba? And we want the residuals to be like that. Kasi ibig sabihin nun, wala na tayong mamamodel dito na AR process. Wala na. Kasi insignificant na lahat. Walang autocorrelation among the residuals. Alright? No? Okay, tingnan natin na. So let's create this object. I'll call it res_ARIMA10. And it is the residuals from your ARIMA 10 model. Take note, I hope you understand, ARIMA 10, ito yung natin. Ito yung ARIMA model natin for the A1 data. So if we create this object, okay, kahit na i-view ko ayaw eh. Ano ba yung laman ng res ARIMA 10? ito yung mga residuals ng, I have to check kung bakit may nag-flash. Okay, so let's try to see, no? Subukan natin i-model to, yung residuals na to. So by using auto.arima ng residuals ARMA 10, trace is equal to 2. Let's run this. Okay, what do you have? No? So mga nagsasuggest siya, no? ARIMA 202, ARIMA 100, etc. No? Tapos, ang lumabas dito, okay. Now, refitting the best model without approximations. So it's an ARIMA 000. Okay? So ito yung best model. Ibig sabihin, walang AR component, walang MA component, hindi kailangan difference. So this is what we call white noise. Okay? Residuals to ng ano natin, ng minodel natin. So yung residuals natin, okay siya, white noise siya. Ibig sabihin, nothing to model here. Okay. So dito, what if we model A1 as ARMA 01? Okay. Again guys, ano yung A1? A1 is the object na create natin kanina, yung from the ARIMA, ARIMA.sim, simulated value to. Okay, ito yung 1,000 observations. Tapos, di ba, alam natin na ang model natin is ARIMA 10 or ARIMA 100. What if minodel natin si A1 as MA 001. So here I'm creating this object ARMA 10X. X kasi so mali, no? ARIMA A1 order 0 order C001. So hindi yung AR component, hindi difference, but the MA component. So let's run this. Tingnan natin kung ano mangyayari, no? Kung minodel natin yung A1 object natin, kung mali yung pag-model natin, ano lumalabas nito? Okay? So your MA1 component is 0.6168. Ito yung coefficient natin. And then you see the AIC is 3211. Mataas siya relative to yung ARMA 10. Pero ituloy pa rin natin, no? Tapos ang gawin natin, tingnan natin yung autocorrelation ng residuals. Okay? So ito yung model natin na ARMA 01. Tapos i-plot natin yung residuals. Let's see what happens. Anong klaseng residuals ang makikita natin dito? Okay, tingnan nyo guys. So, may mga significant lags pa siya. In fact, dito, pinapakita sa atin dito na may dalawang lags na significant dito sa PACF. No? Okay? And then dito, medyo slow decay sa MA. So this is telling us really that AR yung natin, AR, hindi MA yung series natin. So dito nagkamali tayo ng nagkamali tayo ng pag-model. Okay? Tapos prinat natin yung autocorrelation niya. Unlike dun sa kanina na ito yung sa AR1 process natin, wala nang significant spikes yung autocorrelation. Ito, this one on the other hand, ito, no? May mga significant spikes. Okay, which means that our residuals are not white noise. Ibig sabihin nun, yung model natin was not able to capture some of the process. No? Kasi may mga significant spikes pa tayo dito sa residuals. Okay, and in fact, if we try to model the residuals, ito, di ba, ARMA 10X2, ito yung model natin for the MA process, and then yung residuals natin, let's see what will happen if we model the residuals. Ang lumalabas na dito na, ayun, pwede pa natin i-model yung residuals. Okay, in fact, AR2, ARMA 200 yung residuals natin. You can see my AR1 process, my AR2 process. So, ibig sabihin nun, yung first na model natin, where we modeled the AR1 process as an MA1 process, resulted into residuals that were not white noise and residuals that could still be modeled. In fact, yung residuals natin, AR2 process siya. So may mali dun sa ginawa natin kanina na ginawa nating MA process. Okay? So the lesson there is that pag mamali tayo ng model, yung residuals natin will show that they are not white noise. Okay? Yung residuals ng model natin, kung mali yung in-identify natin, it will show that the residuals are not white noise. Ano ibig sabihin white noise? Yung white noise, okay, illustrate ko ulit, ganito yung yung PACF niya at saka ACF. PACF, ACF. Ibig sabihin nun, wala ka na mamodel dito, wala na mga significant spikes. It means that our residuals are okay. Good siya. Ibig sabihin, our model was able to capture the process, whether it was AR or MA. Pag yung residuals natin may mga significant spikes pa, ibig sabihin nun, hindi pa yun yung model natin hindi pa ma-capture yung mga movement ng data natin. Okay, ito naman quickly, guys, ito mag-aan naman tayo mag-simulate ng MA process, no? So similar lang to sa taas. So very quickly, set that seed ulit tayo. 1, 2, 3. Let's create this object M1 for an MA process. We're going to use the ARIMA.sim again. And then our model is MA is equal to 0.6, 1,000 observations. So this is an MA process, itong M1 na to. So may M1 na tayo dito sa object natin. See here, I now have an M1 object here. No? It's a time series, 1,000 observations. If we plot M1, we expect this to be, of course, this should be stationary. Yeah, stationary siya. Okay. And then, if we get the autocorrelation function, dito natin malalaman kung AR o MA siya. No? And dapat ina-expect natin, dapat MA to. Okay? So take a look at this, guys. So significant spike, pag MA, dito natin tinitingnan sa ACF yan. One or more significant spikes. Dito significant at 1. Ibig sabihin to MA1 to. Kasi significant at 1. And then the PACF yan, slow decay siya. Bumababa over time. Ano siya, yung tawag dito? What's the term for that? Nag-change from positive to negative, positive to negative. No? But this is also slow decay. Slow decay to. Pag ACF, significant spike, candidate yan for MA. Pag si PACF naman, slow decay, then sabi natin, yung process na to is an MA process. Pag si ACF din, significant spike, tapos si ACF, okay. Pag si ACF, significant spike, and the partial ACF, significant spike, then indicative yan na ARIMA process yan. Okay, so this was very important before because dati manual talaga yung pag-determine ng model. Ngayon kasi may auto.arima na tayo eh. But it pays to understand. No? It pays to understand where the auto.arima is coming. Okay? Right, and then so dito, nag-create tayo ng model, ano? Okay, ARIMA 01. 0 yung AR, 1 yung MA. ARIMA yung function na gagamitin natin. Okay, let's see ano yung model dito. So the model for this one is natin. The model for this one is MA1 nga, no? And then MA1 5876, which is close to 0.6. Okay? 0.5876 ito yan. Kasi simulated to eh. So 5876 atin. Okay, and then let's plot again the residuals. Ang model natin, O1 residuals. Plot natin. Okay, expected white noise siya. Tapos yung AC niya, yung autocorrelation, tingnan na ulit natin. Ano yung autocorrelation ng, okay, there, white noise siya. White noise. Sabihin, tama yung pag-model natin. Ano tayo? Nag-simulate ng MA function. Okay? So, nung pinat natin si MA function, we can see immediately that it's a stationary data series. Tapos, sinolve ulit natin, no? Using ARIMA function. And then it turns out that 0.58 yung coefficient niya, which is very close to the 0.6 na simulated value natin. And then we check the error term. Okay, we plotted the autocorrelation of the error term. Okay siya. Turns out that it's white noise. Okay yung model natin. And then ito, I will not run this. No? Parang reverse to ng kanina. MA process to. Pag i-run natin as AR, magkaka-error din tayo dun sa ano. Magkaka-error tayo dun sa AR process natin. Okay. All right. Here, okay, dito naman, no? Let's see. This is now a simulation, ARIMA 11. We're simulating a model where the AR component is 0.4 and the MA component is 0.5. By the way, guys, yung theta, yung component natin ng AR plus yung component ng MA, dapat pag inad natin sila, they should be less than 1. Okay, each one of this should be less than 1, and the sum of both components should be less than 1. Okay, so please do a little bit of research on the coefficients of an AR and an MA process. Okay, so let's. Okay, so sige, sabay-sabay natin i-run to, no? Set that seed ulit tayo. And then we're creating this object, ARIMA 11. Ipapaplot natin siya, ARIMA 11, and then tingnan natin yung autocorrelation. So let's run this all together. There. Okay, first, we have the time series. So this is an ARIMA 11 process, and it's supposed to be stationary. Kaya nga tingnan mo yung natin time series na to. And then let's take a look at the ACF. There. Okay? So dito, makikita natin may mga significant spikes. Hindi naman talaga sa slow decay. May mga significant spikes siya sa lag 1, lag 2, lag 3. Okay? And dito may mga halos negligible naman yung pagiging significant niya. So since sa ACF meron tayong mga significant spikes, it's indicative that this can be an AR, an MA process. Tapos dito din sa PACF, may mga significant spikes. Okay, hindi naman siya slow decay. Significant spikes siya, so it means that this can also be an AR process. So significant spike at ACF, significant spike at PACF, indicating that this can be an ARIMA process. Okay? And indeed, it's an ARIMA process kasi take note, sinimulate lang natin ito. No? ARIMA.sim, AR component, MA component. Okay. So, sige, kunin natin yung best model nito using the auto.arima. Trace is equal to true. Alright. So there we have different models, and the best model daw is yun, guys. The best model is ayan. Best model is ARIMA 10, which is your 1 yung lag ng AR, 1 din yung lag ng MA. Which we're expecting kasi ARIMA, ARMA 112, di ba? Okay, so this is the AR component, 0.38, which is very close to 0.4. Baka kasi 0.4 yung ginamit natin ng simulation. At saka 0.6. 0.6 yung MA. Tama ba? 0.6 ba? Hindi, 0.5 pala. No? 0.5. 0.4 and 0.5. So very close to 0.5. Okay, with the AIC of 2838. So this is the lowest. Okay, so our model is, if we write it, sorry, medyo na iba na dito, ano? Kasi ibang set that's na tayo. So this model should be 0.3851 times our object ARMA 11 T minus 1 plus 0.5425 times, oh wait, but may ganito to, no? Okay, I think dinagdag ko na lang to for another model. I'm sorry about this, guys. So, lagyan natin ng hashtag. Diyan. Ang model natin supposed to be your y sub t is equal to 0.3851 times this is your phi1 times 0.3851 plus epsilon sub t plus 0.5425 times epsilon sub t minus 1. Okay? Ito yung mga components natin. All right, then okay, so dito magsa-simulate tayo ng 2-2 dito, no? Below here. Okay, you can simulate a 2-2 model here. So ang maganda dito, class, is that you can come up with a model muna with a simulated model. Okay, using this ARIMA.sim model is equal to, i-list nyo lang yung AR component, kung dalawa siya, AR is equal to, combine nyo si C, no? Tapos si MA, combine din. So this one, sige, why don't we, okay, dali. So, dito na lang. I-copy ko siya sa console and then i-run natin. X1, okay, and then plot natin. Okay, let's run this. Sa console, i-run ko. We're generating now another model called, another data called X1, and then this data follows an ARMA 2-2 process, dalawang component ng AR, dalawang component ng MA. 1,000 observations then, and then we asked it to be plotted also. Control Enter, yan. Okay, so this is now your X1 object. So we can see that it's also stationary. Kasi ARMA, ano yan, ARMA 2-2. And then let's copy this. Tignan natin yung AC niya. AC X1 max.log is equal to 18. Okay, let's check Okay. So may mga significant spikes sa ACF indicating that this can be an MA process. Dito nga lang hindi natin nakikita na ano, no? Parang MA4 to eh. Looks like it's an MA4 process kasi apat yung significant spikes. Si PACF naman, this is indicating that significant spikes siya. So this is indicating that this is an AR process. Parang AR2. Significant at 1, significant at 2. So can be an AR2 process. Ito, MA process, pwedeng MA4. Pero ano lang yan, guys, we cannot really determine accurately based on the ACF and the PACF kung ano yung model na yan. So let's now create this model. Ito na, auto.arima na lang. Control C, Control V, and let's see what's the best model. All right. Then it tells us that the best model is 202. Yan, tama, no? AR2, MA2. And these are the coefficients na sinasabi niya. Na, ano ba yung model natin? It's here. So yung simulation natin, saan na? Here. 0.4, 0.1, 0.5, 0.2. Point, ano yun? Mali yata ako. 0.4, 0.1, 0.5, 0.2. Okay. So may 0.1, no? 0.4, 0.1, medyo hindi nagtutugma. Tama ba yung tininan ko? AR, 0.4, 0.1, and then 0.5, 0.2. Tama. 0.4, 0.1, so 0.5, 0.2. So hindi siya hindi na siya ganoon ka accurate. Sa bagay, simulated data lang naman yun, nasa taas. So based on the data that was given, na simulated siya, this is the best model. This is the best model. And so, tingnan natin, i-plot natin yung, okay, ito. Tingnan mo natin yung residuals, no? Control C, Control V. So, ano yung tawag sa object natin? What did we name the object? X1 pala, no? Tapos, ang kulang natin dito, hindi natin pinangalanan yung object natin. Dapat dito, nalagay tayo ng mod X1 na lang. Model X1. Kasi kailangan may pangalan yung object natin. Guys, please tell me kung kung if you're not able to follow. Ang ginawa ko, binigyan ko lang yung name natin ng yung object natin ng mod X1 so that we can retrieve any object out of that. So plot yung residuals niya as expected. Okay? And then yung AC natin, autocorrelation. Tingnan natin yung autocorrelation ng residuals natin, which is coming from this one. Control C, Control V, and then max.log. 18 legs. So let's plot this. Okay. Kita din natin guys na, diba? White noise na rin. White noise na rin siya. Okay, so pause muna ako guys. Any questions so far? Any questions? Okay, review lang natin ha. I'm sure medyo sa dami ng details, ano? I'm sure it's not easy to really in one sitting makuha agad natin lahat to. Ang ginagawa natin, we're modeling a time series. Okay, so gusto natin yung time series na yun. If you're going to use the Box-Jenkins approach, yung ARIMA modeling, dapat na-convert natin siya into a stationary time series. What we did was to simulate, di ba? Nag-simulate tayo ng data na that follows an ARIMA process. Okay? And then when we plotted those data, nakikita natin na stationary siya. And then when we use either the ARIMA function or auto.arima, it turned out it gave us the model for that. Tapos yung ARIMA model natin, when we extracted the residuals, plinat natin yung residuals, it turned out that the residuals were also, of course, stationary. Tapos yung plinat natin yung plinat natin yung autocorrelation ng residuals, it turned out that wala na siyang mga significant lags. Which means, ito ano yung mga ganito. So, which is called white noise, diba? White noise ang tawag natin dyan. And we want the model to be like that. Yung residuals niya, white noise na. Wala na tayong may exact na model from that. Kasi white noise na siya. Okay? So, that's the end of the modeling. So, sasabihin na natin kung ano yung model natin. And then based on the residuals at the diagnostic test, okay na yung model natin. Okay? Now, what happens if our data is not stationary? Then we will have to transform the data. Okay, so usually ang magandang gawin, kunin muna natin yung yung log. Kung may non-constant yung variance, kunin natin yung log para ma-address natin yung non-constancy of the variance. And then after that, if there's a trend, kunin natin yung difference. So that now generates a new data set, difference ng log ng data natin. If we do that, then usually na-address na yung non-constant variance at non-constant mean. Tapos saka natin i-model yung ARIMA. Saka natin i-model. So if it was manually, ipa-plot muna natin yung ACF at saka PACF to give us an idea kung anong process kaya yan. AR ba yan o MA ba yan? Then from there, you generate, you come up with a computation kung ano yung coefficients ng AR or MA or ARMA. Depende. Okay. Pero sabi natin ngayon, meron na tayong auto.arima function na siya na mismo yung gagawa ng ano. Siya na mismo magsasabi sa atin kung ano yung proseso ng data. No? So, let's go into that now. Okay, so let's go down. Okay, so these are notes. Guys, inulit lang natin to. No? Na-repeat lang yung process na yan. What's an MA process like? Okay. Now, may mga ano dito, no? May mga notes. Guys, very important to. No? So for our AR1 and MA1 process, yung coefficient, yung A1, dapat it should be between -1 and 1. So pwede siya maging negative, pwede siya maging positive, pero hindi siya pwede lumabas ng 1, -1 or +1. Ganon din si MA component. Okay? So the coefficients of the AR1 and the MA1 can't be greater than 1, and it can't be less than -1. Okay, so ito na ulit na lang, no? Okay. So I would that you read through this. No? All right. So let's now go to this. So iwanan ko na to, guys. So ito, ina-explain lang. Tingnan nyo to, no? 0.9 at saka, sandali just some important comments here. Ito, what happens if the coefficient is greater than 1? Tingnan nyo to, no? I'll call this AR1X. ARIMA.sim, 50 observations. Model is equal to 1.01. Then binigyan natin ng standard deviation. Okay, ano yung M dito? May dinagdag siya na M. Sandali M is 1. M is 1. So dapat i-run muna natin to. Okay. So, sige, I have to discuss this. Sige na nga, let me go back here. Okay, so these are just notes, guys, on I was thinking kung kailangan pa ba i-discuss to. Sige, discuss mo lang to, guys. No? So here, we're creating this object. Let's set that seed. Gawa tayo ng object na AR, autoregressive process. And then we have here apat na apat na coefficients, 0.7, 0.2, -1, and -0.3. Ititingnan natin yung mga differentiation ito. Okay? So, and then we're creating this object ar.mods list. Tapos ito, may function tayo dito na for p in 1 to 4. Ibig sabihin yung p natin, yung 1 to 4 natin, 0.7, 0.2, 0.1, 0.3. Mag-simulate tayo ng ARIMA, 10,000 observations. And then, yung AR natin, okay, from 1 up to P. So, una muna, yung isa lang, 1 up to 1, tapos 1 up to 2, dalawa na, AR2 process na, tapos AR3, 0.7, 0.2, -0.1, at saka yung AR4, 0.7, 0.2, -0.1, saka -0.3. Now, take note, pwedeng ganito yung AR4 natin. Kasi pag inad natin siya, hindi lalampas ng ano. Not one of the coefficients are greater than 1. Okay? Not one is less than -1. Absolute value niya dapat hindi lumampas ng 1. Tapos pag inad natin siya, 0.7, 0.2, that's 0.9, plus -0.1, that's okay lang. So kahit na i-add natin itong apat na to, hindi siya dapat lalampas ng 1. Okay, so that's another characteristic, guys, kapag ARP process na, pag marami ng coefficients. Okay, so let's run this. It will create now an AR1, AR2, itong dalawang to, AR3, at saka AR4. Sige, let's run this. Yan. Okay, so let's take a look at the ARP, Okay, so si ARP natin, and then AR mods natin. Saan si AR mods? Ito, AR mods. It's a list of 4. Okay, so tatlong AR models to, no? Isang AR1, AR2, AR3, AR4. Si AR1, ito yung coefficient niya. Si AR2, 0.7 at saka 0.2. Si AR3, 0.7, 0.2, negative 0.1. Tapos si AR4 yung 4. Okay, so let's okay, i-plot natin. Let's plot this. Let's see what's happening here. Partition down natin yung rows natin. 4 rows and 3 columns. Tapos ipa-plot yung time series. Plot yung time series natin. So there will be 4 time series. AR1, AR2, AR3, AR4. Ipa-plot din yung PACF. Okay. ACF ng AR1, 2, 3, 4 at saka PACF ng AR1, 2, 3, 4. So let's see. Let's run this. Alright. So 4 times 3 siya. 4 models kasi. AR1, 2, 3, 4. Okay. Ito yung AR1 natin. AR2, AR3, AR4. Okay. All of them are stationary. No? Nagkakatalo-talo sila sa ACF. So ACF ng AR1 natin, slow decay, di ba? So this is indicative that pwedeng AR process to. But pag tinignan natin dito sa PACF, significant lang siya at 1. Diba? Itong AR2 natin, okay, slow decay din, and then significant at 2 lags. No? Si AR3, significant at 1, 2, at saka 3. Si AR4, significant at 1, 2, 3, 4. So kita natin yung differences nila. AR1, AR2, AR3, and AR4. Okay. So, and then, okay. Now let's do the same for MA. MA process naman. Ganun din, no? Nag-create tayo ng apat na MA process. MA1, MA2 yung dalawang to, MA3 yung tatlo, at saka MA4. Again, pwede siya. Pwede siya. Now, if I, for example, experiment lang ha, ginawa ko tong 0.9. 0.9 tapos 0.2. Notice na yung sum niya, more than 1 na, hindi na pwede ito. Mag-error na. So, run ko to. Okay, ano nangyari? 0.9, 0.2. Oh, wait ha? Ba't nag-ano? 9. Tapos 0.2. Tapos ano to ah? Ng 1. Okay, dapat hindi pwede yun. Hindi pa pwede ito guys kasi mag-exceed ng 1 yung sum nito eh. Okay. Sige. Anyway guys, I'll let me note that. Time na, no? Sige, hopefully masagot natin ito mamaya. Kasi dapat, hindi siya dapat mag-run kasi kung 0.9 to, 0.9 plus 0.2, it's more than 1. So, hindi siya pwedeng lumabas na 1. Okay, anyway, sige. I-run natin itong MA, pinan ko ulit. And then, i-run ulit natin yung plot natin. This is just to illustrate to you yung, parang naulit lang to kanina, just to reinforce the point that, okay, take a look at the, take a look at the, still, yung plot natin, mga ano pa rin, stationary. Pero, sa MA1, significant at lag 1. Okay, ito yung lag 1 natin. Significant at lag, ito medyo significant dito sa 2, but hindi masyado apparent. Sa MA3, okay, hindi siya masyado apparent yung mga significant dito sa, sa ACF, but kita natin ang mga significant spikes dito. Tapos dito sa PACF, medyo may slow decay, but it's not really apparent. So anong gusto mong sabihin dito? Before, when you had to determine kung anong model based on the ACF and the PACF, it's really quite difficult kasi manual. No? Minamanual namin. Pero ngayon, guys, with the auto.arima, it really is a lot of help. No? Na ganun yung, na mas madali na ma-determine kung ano yung ARIMA function. Okay, so tonight, guys, ang gagawin natin, gagamitin natin si quant mode. Okay? So magda-download tayo ng isang share. Siguro si Apple na lang din. Tapos, imo-model natin si Apple. Pero ang hindi natin imo-model si Apple, ang imo-model natin si returns ng Apple. Okay? Kasi sa finance, ang mas interested tayo dun sa returns ng financial asset rather than the price of the asset itself. Okay. So I have 2 more minutes. Yun lang natin dito. No? So this is from the quant mode package. May I request you to try this class now? So sa quant mode package, merong get symbols function. And then yan, sabi niya, nag-download siya ng AAPL na object. If you take a look at the head ng AAPL, so kita natin dito. Ayan. So ito yung date, ito yung opening, high, low, close, volume, and adjusted close ng Apple share. So we can download directly from Yahoo Finance yung mga ano na to, yung mga prices na to. Okay, so for tonight, we're going to use the Apple. I-plot lang natin sandali. Ito. Okay. So view structure ni Apple. Ay, wait. Rename ko si big letter na small letter. So, ito yung ano niya, no? Ito yung data niya. Notice, guys. Notice, ang kaibahan ng XTS object is that the data, the date is here. Nasa column siya dito. Okay? So later tonight, we're going to hopefully matapos natin itong pagmamodel ng Apple stock. No? So we're going to use ARIMA. Titingnan natin kung ano yung ARIMA model nitong AAPL na data. Okay, so let me stop share.